Hello, in this video we're going to be working on the CodeCheck Python Exercises, the assignment week 9 lists. Let me go into full screen. Assume scores is a list of integers. Fill in the following code snippets. Set the first element to 12. Well, they say the list is called scores, so I'll copy that, scores. And in most languages, including Python, to get the first element at all, just to refer to the first element, you need brackets to refer to a particular element. And the first element will be at index 0 because lists are 0 indexed. So for something that was 10 long, it would go from index 0 to index 9. And then we need to not just get that value, we need to actually set that value. So we'll say scores at 0 is equal to 12, the value, and hit enter. Yes. Okay, set now the second element to contain the same value of scores at index 4, or the fifth element of the list. So we'll say scores at second element, so index, sorry, not index 2, common mistake, index 1 will be the same as what is currently at scores index 4, which would be the fifth item. Set variable size to contain the number of elements in the scores list. So you could go through and add this up one by one with a loop, but there is a convenience function in Python that is len of scores. You just pass in the list to the len function, which is on the global scope always. Set the last element to 20. So the last element, you could do this two different ways. One way would be at scores, so len of scores, so that would be some particular value. Say it's a list of length 10, you would get 10, but we only go, for a list of length 10, the indexes go from 0 to 9 instead of 1 to 10. So we can't use 10 or we would be out of bounds. We actually have to subtract 1 from that, minus 1, like this. And Python, if they'll let us do this, Python actually allows negative indices. Unlike some languages, Python will allow you to do scores at -1, which means the negative first position or the last item in a list like this. So let's see if they allow that. They don't seem to like the negative first position, so I think they want us to just do len of scores -1. And I am not reading the instructions because they said set the last element to 20, not just get the last element. So I'll say scores at, let's see if they'll let us do at -1 or at len -1 is equal to the value 20, and then we'll hit enter. And yes, see, they modified what I did, but they accepted it. And I got 50%, so I would want to probably redo this to get full credit. So we'll say set the first element to 12, scores at 0 equals 12, scores at 1 equals scores at 4, size equals len of scores, and scores at, I'll do it the long way, len of scores, close paren, -1, close bracket, equals 20. Complete the following program that multiplies each element of a list by 5. Oh, this is a fun one. So multiplying each element of a list by 5, it's not saying to create a function, it's just saying to do it. So the naive way to do this would be to just go for, they would just go through the values themselves. You might think you could do for val in values, and then you could just say, well, val equals val times 5, or like val times equals 5. but this, I believe, is not going to work. I'd be surprised if this works. Yes, not going to work. And why is that? Actual is coming out as the exact same thing as we started with. So why would that be? The reason is because val is not actually referring to the data at the position 2. Val is a temporary variable that the for loop is creating for us to represent the value. It's a bit confusing, but it's saying, okay, I'll go and grab you what's at the index 0. But actually changing that, you're just changing a copy of that value inside that list. So if you actually want to change it, you're going to need to refer specifically to the item itself. So what that would mean is instead of for val in values, you could do something like for I in range values or len of values. So range would take like the size of the range that you want to go through. So for I starting at 0 up to whatever you pass in -1. So if you passed in 10, it would go from 0 to 9, I believe. And then if you passed in the range len of values, then it'll go from 0 to the last valid index of this list. So for I in range len values, then all we have is an index that goes 0, 1, 2, 3, 4, and we just want to say take values at I, the index I. We could call that anything. We just chose to call it I because that's common choice. And then we say equals to values at I times 5, or times equals 5. And they're happy with that. Now, how would I change this? Well, there would be a simpler way to do this, which would be to use a functional approach. And that would be we define a function that multiplies any given value by 5, and then we just map that function across the whole list. That would be a functional approach, much, much simpler in my opinion, once you actually understand what the functional approach is doing. So in Python, there's a built-in functional higher order function called map, which takes in a collection. It could be a map object, it could be a filter object, it could be a range, it could be a list, it could be a set, it could be a dictionary, I believe. It could be any kind of data structure that has many sequential pieces of it, and then it'll go over each one of those pieces, and it will apply a function, and then we'll return a result that is, turning the original thing into mapping each of those items to new values in a new data structure. So, for example, exactly what we want to do here. Take the list that looks like this and return a list of the same size and shape, but now the values are transformed by some function. So the transformation function is, I can call that transformation fn, is going to be equal to a lambda, so a function that takes an argument, arg here, I'll call that arg for now, and returns something about the arg. So arg times 5 in this case. This is just saying we don't need the return word here. It's just saying return arg multiplied by 5, and we can call that something more conventional, like somebody might use the value, the name x. So take x and return x multiplied by 5, and then that is stored as a concept of how to change a value, and it's called, that concept or that function is called transformation function. So then we just map the transformation function onto the collection, which is called values, and we're going to get a map object, which is not our intended result. Our intended result is another list. So unfortunately, we have to do something a bit weird, and we have to wrap this in a list converter that just basically takes the concept of the map, and it actually calculates all the values, because by default, map is lazy, and it just says, I'll only compute those values when you're actually asking for them. It's really kind of hard to wrap your head around, but that is just how map behaves in Python. So we will need to list map transformation function values, and weirdly, we actually don't have to store this into anything to make this transformation happen, this function will run, but the result of the map list is going to be the list that we want, and so we actually need to replace. By default, it's not going to replace, it's going to create an entirely new list that is the values multiplied by 5. So in order to update that, we will need to say values, replace the entire values list with this new list that is a mapping of the transformation function onto the values. Let's see if that works. And it works just fine. So the even more concise version of this would be to take this and just, we don't even call it transformation function. We just put it in line like that. And though this is probably the most concise version, I would argue that a different way of expressing each of the maps into expressing the map object into a list would be a little bit more readable if we use the Python list comprehension, which is looks something like this. So we have an empty list object like this. This is just the empty list, and then into that we're going to say the values of this list will be defined by, let's call it anything. So call it A. Call it A, where A for A in. So A for A in a collection, a sequence, which could be anything. Again, a list, a map, a dictionary, a set, a filter, and we take, say, for A for A in map lambda x times 5 on values. So these two lines are essentially doing the same thing, but the list comprehension maybe is a little bit more readable. Readability-wise, I would argue actually not having the lambda inline would be better for readability. So saying, mult by 5 is what that function could be called, like we called it transformation function before. This is a little more descriptive to say mult by 5. Say mult by 5 is a lambda function that takes x and multiplies by 5. We're going to map that multiplier across the values, and then we're going to construct a list for the elements A for A in map. So each element will be A in a given computation of that element, and we'll do that for each given A in the collection of the map object. Weird to say out loud. It seems unnecessary, but it's just a way to get that map object to be fully evaluated back into a list. Too much information, huh? Okay, complete the following program that removes the maximum value from a given list. All right, once again, there's kind of the first idea that comes to my head, and then there's the naive option that you might try. So before I used a for loop, I could have used a while loop back there. So maybe we could use a while loop here. So find the maximum value. All right, well, we know we shouldn't use the word max, because you saw it just got highlighted. So there is a max function in Python. So we maybe should use largest as our name, because that's not going to conflict with the max in Python. So largest is, let's say, we'll start as, in this case, we know the list will never be empty, so it's not going to be a violation to pick the first item by default, because we know there is a first item. That could happen, though, that if we want this to be like a general function, we might be given a values that has no first value, and that would be pretty challenging. I do believe there is, let's see if infinity is something. So I think there is actually an infinity in Python. And why would you ever want to talk about infinity? Well, various math reasons, but also infinity will always be larger than any number, and negative infinity will always be smaller than any given number. So there is a way to do this in Python. I just don't remember it. So Python negative infinity. We're going to look that up. And so we can use AI, although I'm sure it's elsewhere on Google as well. So float minus inf is what they're using here. I thought there was a negative one. Okay, so the math module requires import math. We can do negative math.inf, inf. So we could do something like this. We could say from math import inf as infinity. Just for readability, we could use inf or infinity. And then largest is going to be infinity. And then that's our default. We know infinity is the largest thing possible ever. And then while, we'll need a counter to check if while the current index, I'll say IDX, while the current index is less than the len of the values list. So we'll go up for a 10 size list. We'll go from 0, 1, 2, 3, 4 up to 9. And 9 is less than 10, and 10 is the length of values. So that concept will apply no matter what the length of it would be. And so I mentioned going from 0 up to there. So we're going to need to start at current index is equal to 0 to get the first thing in the list. And then we will say, we'll check if, we've done this in past videos or past lessons, if the current value, so let's say current val is equal to values at current index, if that current val is greater than the largest, and notice actually we don't want it to be infinity here. The largest starting at infinity means nothing will ever beat infinity. So we actually want largest equals minus infinity, the smallest possible number, so that almost anything we pick is going to be bigger than the smallest possible number. So say if current value is greater than largest, then largest is equal to current value. And then we will need to make sure that we take our current index and we plus equals to 1. We add 1 to the current index so that we can move along and we have our exit condition. And then we need to remove that maximum value from the list. There are multiple ways to remove a value from a list, but one of them, Python has this weird syntax of del. So it's like del, if we want to remove the first item in the list. I just happen to remember this, but honestly, it's pretty obscure, and it's to me, it's kind of weird syntax compared to other programming languages. If we want to delete the first value, I believe we would do it like this: del space values at 0. Again, I think that's kind of weird. The other thing that we could do would be we could go through the list and remove the value with maybe like a dot remove function, remove at index. So I don't know what that would look like exactly, but something like values dot remove at, and then the value, at the index 0, something like this, and then that would return the new list or something like that. Whereas this edits the list in place. This function call might return the new list. And then they didn't really tell us what happens if, we have the largest value is in two different places. Maybe there were two 100s. Do we remove just the first one? Do we remove both of them? Do we remove just the second one? It's not really clear, but in this particular input, there's only one largest, so they're kind of giving us an easy out that we don't really have to deal with that. So let's see if we can just remove at index, or remove the remove value of, let's say we want to remove the value 100. We've currently found the largest in the largest variable, so then we could remove it that way. So let's see, Python remove value from list. So we've got mylist.remove apple. I believe that is valid, and so that's pretty much exactly what we want to do. So it's kind of weird we did this whole big long thing, which is too much code to be honest, and then we're just going to call an easy out function to get rid of that. There's also, I believe, if they say, yeah, we can list.pop at index, so this would be like removing, instead of by the value, of by the index. We have del at mylist at index. But then we need to know the index, so we could use something like Python index of, there actually is a function for this. So if we want the index of banana, we could do list.index of a particular thing. But again, we've just kind of looked through the list. So really, we should be keeping track of the largest index too as well. So current index, maybe we should start the current index at -1, and then maybe we should increase the index as soon as we get in there so that we're at 0 to start, but we're at -1 if the list was empty, and that would indicate that like there is no index where there's a largest. And we'll also, instead of just keeping track of the largest value here, we'll also keep track of the largest index. So we'll say largest index for IDX is current index, which is going to start at -1, but then we'll update it as needed. So we'll say largest is current val, and we need to keep track of that so we know what the last largest was and see if we're bigger than the last largest. We still need to keep track of that, but then we'll need to say largest index is going to be equal to the current index whenever we find something bigger. And then we can do just simply values, del values at current index. This would be the function to do that, I believe. And we did horribly. So what happened? Values, list index out of range. Of course, of course. So let's see what they're expecting this. So yeah, maybe they do need us to do an if guard or a check to make sure that current index is a valid index. So if current index is, we start at -1. So if we say if current index is greater than 0, then we'll del it. And list index is out of range. So it's probably an off by 1 error. So we start at -1. Immediately we make it 0. So we're saying values at current index. Where are they complaining? Current val equals values at current index is becoming a problem. If current index is less than len values. So we probably need this to be different. If current index, so it starts at -1, is less than len values, we actually need if current index plus 1 is less than len values, because we're incrementing this in a different place and starting with -1, maybe. Oof, okay. Correct on this one, and then here we're wrong on this one. So we have the input where 100 is the biggest. The actual was we took out 30. Why did we take out 30? And we were supposed to take out 100. So if current val is greater than largest, then largest is equal to current val and largest index is equal to current index. That logic seems right. Okay, so we're saying if current index is greater than 0, then delete, yeah, simply, we're always deleting the current index, which always is going to end at the last index in the list. This would be a common mistake someone could make, who is not me. So we should have done the largest index, which we should capture as being the index for the value 100, and now we're passing. Okay, but so what would have been easier here? We could have just replaced this entire thing with the Python max function, unfortunately. So Python index of, we could do, fruits.index. So values dot index of what value? The max value of values. And then that would give us the index. And so we want to del the values at the index values dot index of the max of values. And this might be the thing that we could do right here. I don't know if we might still need that if guard, but I'm not sure. So let's see what happens here. Yep, seems like it works just the same. So all that code, all that thinking, where secretly I knew that we could have just done this. And again, there are a bunch of different ways that you could have done this. Like for example, I think there's like a Python func tools or iter tools list without certain value, something like that. And this would be filter false or partial. So value to remove, we have numbers, value to remove is 2. Create a function that checks if x is the target value. Filter false, so we're filtering if the value is this particular value and the result is turning that filter iterator into a list. It's a bit convoluted, so I would not go that way. Complete the following program that creates a duplicate version of the list, but with the elements stored in reverse order from the original. That is very easy to do in Python. There's a shortcut, but of course I'm not going to show you the shortcut. I'm going to go through it with the naive approach. So new values is, we're just going to say, we could use a for loop, a while loop, we could map it, we could reverse it automatically. So let's just do, let's just do just a while loop, which would be the very simple thing to do. So the current index or current I, let's say cur I, is going to be equal to starting at the len of the origvals minus 1. That's the last valid index. That'll be 30. And we just want to start there. And then we want to stop when, so go until while this is still true, cur I is greater than or equal to 0. Because 0 itself would be valid. And then during that, we will just say take the origvals at cur I and put that into new values. So it'll be like new values. There'd be 2 ways to do this. Like I think new values dot concat or append or something like that. Or push, it might be push. Python append value to list. I know you can use the plus operator, but that's a little atypical of programming languages. So I guess we can do append. I thought it was separate, so I'm a little dubious of that AI answer there, but you might be able to do list.append, so new values.append, and we'll take this orig values at cur I, and we're just literally appending as we go, which you would think would make the exact list, but because we're starting from the end and going to the beginning, that's doing what we want. Oh, this is going to run forever. So yeah, we have a memory error because this while loop goes forever because we never changed cur I. So we need to say cur I minus equals cur I is equal to cur I minus 1. And there we go, we passed. So really what would I do with this is I would take the shortcut, the Python shortcut. And by the way, this new values.append could be done in different ways as well. Like you could do, I think you could do new vals concat and concat an entire new list. And that entire new list would need to be a list instead of just an element of the list like that. I think you could do that. And nope, list has no attribute concat. So Python concat, I would look up. Plus operator, yeah, I know that. Join. Pandas, yeah, I guess they don't have, maybe there is no concat by default because they have the plus. So you would just do something like new values plus equals, so adding to the end of it a list that just contains the new element, and that is as good as combining those two lists into one flat list. And the really easy way to do this would be new values equals reversed with a D, with a ED. So reverse shuffles and reverses the list in place. Reverse ED is functional, so it takes the original list and doesn't modify it, but makes a copy that is reversed of the original values, like that. And could I be wrong? It's a reversed iterator. So reversed is lazy. It doesn't actually turn it back into a list and look at every single value unless you ask it to. So you need to wrap it in a list or do a list comprehension. This one's getting pretty long, huh? Implement the fill function that fills all elements of a list with a given value. For example, the call fill scores 10 should fill all elements of the list with the value 10. Fills all elements of a list with a given value. So many ways to do this. Seems a bit silly to be doing this, but the really easy way to do this would be fill list data. Okay, so it fills all elements of a list. It doesn't return a new list. It's actually needing to edit the list in place. So you're going to need to somehow actually need to access the data at, particular index, whatever that would be. And so because it is in place and we're not creating a copy, we can't easily use a functional approach. Like what we might want to do is just say like data equals list comprehension, x for x in map data with the lambda function, which takes a certain value underscore y. We don't really care about that value because we're going to discard it, and we just fill in the value, which was passed into the larger function of, say, 10, for example. And so it's just going to say for each value of the list we don't care about, discard it and replace it with value across the entire data, and then turn it into a list with x for x in map. And then you would have data would now be this. But again, this is the problem where data is not actually the editable version of the data object. It's like a name for what got passed in. So the function is going to get like a copy of that, and we're going to edit our copy, but we're not actually editing the original, unfortunately. So to do this, what you would need to do is just go through and, for example, you could make a def change at, which would take a particular index, which is a int, and it would return nothing but just take an action during that. And so the action would be to look at data and change the value at index and make it equal to the value that we want it to. Change to value at, and then at would be the index. So at a particular index, change the value. And then we would want to, for I in range len data, so for each of the indices inside of the, for the data list, then we want to just execute the change change value at function. Or this is actually silly to do now, I realize, because it's just really a one-liner. So it's just doing this. The only reason you might want it is if you were using a little bit of a more functional approach, which you'll see. You can see in a second, but like for I in range len data, data at index equals value would probably be the simplest way to do this. An index, of course, is not defined, so that's because I called it I here, so I need to match my naming. And that worked fine. But if I did want to do a functional approach, I might do change value at, or use a lambda function. And then instead of doing for I in range, I would say some way, again, if I do a map object, it's lazy, so it's not going to execute unless I turn it into a list or, do a for loop over it or something like that. So I could do something like for underscore I don't care in in map. So I'm going to actually look at each thing in the map. This is another way to get a map to actually execute all the things. I'm just going to say pass, and this can be on its new line like in a normal for loop, or it could actually be on its own. Pass just means I think it's pass and not continue. It might be continue. Pass means like let me put nothing here. Continue is like swing around to the next part of the loop. It might not matter, which I did. But for I don't care in map of something, execute that code. So this is just another way of doing a for loop. And inside that, I would say something like change value at, and I would do that across all of and now I have indices. So I would need a thing that has the indices like, range, len, values, for example. And values is not defined. And yeah, it was not called values, it was called data, my bad. And that's going to work fine. Again, this is just kind of using a for loop. So if you wanted to make this look a little bit more functional, you would do like list, and then you would wrap this map part in parentheses for passing into the list. And that would work. And then instead of doing this, this could be a lambda. So it could be, instead of change value at, you could do lambda, an unnamed lambda function, which takes I don't care and returns it doesn't really matter, but it takes this action, and this action can maybe resolves to a value, but we actually don't care because the ultimate list object is not, we don't do anything with it. We just need to call the list to get the map to run. And yeah, it's a bit, cannot contain assignment. Perhaps you meant equals equals. So this is where we're hitting up the limitations of a lambda function, because a lambda function is supposed to like take something in and send something out, whereas a definition is more well suited to, I just want to take a side effect action without actually returning anything, which this function returns nothing. We can notate that with return none, returns none as an annotation, like that. So this is maybe a functional way to do this. Again, a bit weird to see if you are more used to for loops and while loops. And that concludes this video. Thanks for watching.